Hi, welcome to Gmsh tutorial prepared by QuickerSim team. You can use your Gmsh meshes in QuickerSim CFD toolbox for MATLAB, and you can download the free version of our software from www.QuickerSim.com. Alright, let's go right now to the first tutorial on Gmsh fundamentals. What we are going to do and what we are going to cover in this tutorial is the description of the graphical user interface of Gmsh. Then we will talk about menus, philosophy and workflow, geometry creation. In the first part we are going to cover the simple 2D geometries. Then we'll talk about selecting boundary conditions for your solver, and in the end we are going to talk about mesh generation in 2D. This is the outline for our first tutorial, but in the two next parts we will be talking about import of external CAD files and the meshing of 3D geometries, then control mesh resolution in an automatic manner, and control a number of subdivisions on certain lines so that you can refine your mesh in places that are most critical for you. And in the third tutorial we are going to talk about more advanced topics, how you can automate your work with Gmsh by scripting and parameterizing your geometry, how you can define size fields that will give you additional control of your mesh resolution at certain in certain subdomains or subregions. Alright, so let's go right now to Gmsh. Once you have downloaded the software from gmsh.info, you will see a window like that. What you should know about Gmsh is that it is a software which combines geometry creation, mesh creation, so it is preprocessor, CAD modeler and mesh generator, and finally it is also a post-processing tool. We are going to focus on pre-processing capabilities of Gmsh. So we are going to show you the workflow, how it looks like. You should see this tree on the left hand side, where you will see that you got two most important modules, two most important for us today. This is geometry and mesh. Under geometry you can find elementary entities and physical groups. Basically, elementary entities are geometrical entities where when you want to create your geometry, you will be going to elementary entities, add, and you can create points, straight lines, splines, B-splines, circle, arc, plane surfaces, ruled surfaces, and volumes. You have got also a number of different geometry creation and geometry manipulation operations like rotate, scale, symmetry, split, etc. And apart from elementary entities, you've got physical groups. Basically, this section is needed when you want to define your boundary conditions, and you will have possibility to add physical lines, surfaces, or volumes. Then you can see that apart from geometry module, you got the mesh module. You can define size fields, transfined lines, which will be needed to define the mesh resolution. But you've got these tools for 1D mesh generation, 2D mesh generation, and 3D mesh generation. You can also change order of your mesh to a higher order, and you've got a number of tools to inspect and refine your mesh, but this will be things that we are going to cover in the next tutorial. Alright, so let's start with something very simple. We will create a two-dimensional geometry. So we are going to create a two-dimensional geometry of an L shape. So what we are going to, the workflow in Gmsh is that you first of all create the geometry, and then you create the mesh. That is probably clear, but when you want to create geometry, you first need to create points, then after creating points you go to creating lines, and finally you go to creation of surfaces, which is enough in 2D, but if you want to go to 3D, you then go to creating volumes. Alright, so let's start creating points. Let's start with 0, 0, 0, add point, then let's change x to 5, y to 5, then x to 4, y to 1, and finally x to 0. So we've got points distributed here, 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 and here. And what we are going to do is we are going to create an L-shaped geometry. So we are going to do a straight line, and we are simply selecting points once again here and here. We are doing all these operations with the left mouse button. And that's it. We have created a very simple geometry. Right now what we are going to do, we are going to create a mesh in this geometry, but the Gmsh philosophy is the following. We have to create a surface and define then physical domain. So it's not enough to only create lines. We are selecting plane surface, and let's simply choose surface boundary. If Gmsh is able to figure out what is the boundary of the plane surface, then it selects it automatically. Otherwise, you would need to select it manually. All right. You should see that these dot lines represent the surface. If you don't see this, you should go to Tools, Options, and then under Geometry you would find Surfaces, and this is one of the dialog boxes that will be needed in a minute, so you should start getting used to that. Alright. We have created the geometry. If we are going to move to the solver, whatever solver it should be, and this can be a structured solver, this can be a CFD solver. In each of them, you need to select boundary conditions. You will need to impose boundary conditions. So to do that, we need to create physical groups in the mesh, because this is the way how, for example, QuickerSim CFD toolbox for MATLAB will, but many other solvers in the same manner will be detecting the boundary conditions. So of course the boundary conditions in the 2D case will be should be imposed as boundaries, so at lines. So we're going to physical groups at line. And you can specify the name of your boundary here, like, for example, say inlet. I will at this point make a comment. The current version of QuickerSim CFD Toolbox does not support text names, so you should leave it blank. This support will be added in one of the feature versions, but if you get any errors, this might be that you've got the version which doesn't support these text names. But anyway, let's try to define it here for any different solver if it supports text lines, text names. Let's say this is inlet, and then you need to specify just E. Let's say this will be outlet and select this one. Then let's say wall bottom, and this will be sorry, maybe it's not only bottom, but these two lines will be one boundary condition. We are accepting our selection with E button on the keyboard, and wall top will be the other one. Alright, once again hit E, and that's almost it. We need to select physical surface, so let's say this is fluid, and we are selecting the plane surface. Great. Right now we are prepared to generate the mesh, but before we do it, we would like to check whether we have defined all the names correctly. So we will show you how to check this. It is very important that you personally have a look at all these options. Probably under File you will not find many interesting things at the moment, but Tools is a very important menu. If you go to Statistics, you can find some simple statistics about geometry, but and you can see that you've got 6 points, 6 lines, 1 surface, and 5 physical groups. Alright, so this is our first check. 1, 2, 3, 4, and 5 is the surface. Alright, so we have created 5 physical groups. On the mesh you haven't got anything interesting right now, but we will have something really interesting once we generate the mesh. What is then? Manipulator is a pretty useful tool. If you manipulate your geometry in a manner and you want to rest it to the original view, this is a very nice tool. What is more, visibility is the thing that we are most interested in right now. You can see that you've got two most important options here. You can select either elementary entities, which are your all geometrical entities. Okay, if you select line 1, this is your first geometrical line, and so on. With Ctrl A you can select all of them, so you come back to your original view. And if you select physical groups, you have your physical groups, so basically your future boundary conditions in your solver. And alright, let's check line number 1, inlet. This is what we wanted to have. Then outlet, wall bottom, wall top. Alright, so we have checked basically everything. Surface is everything. That's good. I will make one more comment for users of QuickerSim CFD Toolbox. If your version does not support these text names, you will need to know that these physical groups IDs are the way how you specify your boundary conditions in the solver. So you can check what. Alright, so the physical group with ID 1 will be your inlet, 2 will be your outlet, 3 and 4 will be your walls, and this is something that you need to remember when going to QuickerSim CFD Toolbox. The other way to check the same is to go to the next dialog window. If you select Tools Options, Let's go to geometry on the left hand side and then visibility, and you can tick that you want to see line labels, but we are not interested in elementary tags. We would rather be interested in physical tags. And right now you see you get 1 inlet, 2 outlet, 3 and 3 are these 2 walls, and 4 are these 2 walls. If you should be interested, you can also select point labels, but you need to switch to elementary tags because we haven't chosen any physical points, so you wouldn't have anything more here. But right now you can see that you got numeration, indexation of your points. You can do the same with surface labels, which is right now not that important, but we are showing this to you so that you are aware of the options that might be really interesting for you. Under general, you can also find something pretty useful. If you go to axis, you can select, for example, simple axis, and then you've got some kind of way to figure out how big your geometry is. Of course, probably if you are creating the geometry by your own, this is not that much needed for you, but if you import an external geometry file, in many ways you would like to check where it is located in space, how big it is, and so on. So remember, general, axis, simple axis. I will switch it off, so I will select it. I will change the settings to none. Options and mesh will be important for us later on when we will be going to display the mesh. Alright, so once we have created that, we could basically collapse elementary entities, collapse physical groups, basically collapse the geometry module, and select mesh. In this first tutorial, we are not going to talk about mesh resolution and how to refine mesh in a bit more advanced way. So we are going to focus on the on the simplest way of creating mesh. So this is really extremely simple. If you just open mesh, you click on 1D, then on 2D, and alright, in my it is drawn with yellow, so you probably don't see much on the movie. But what we could do is we could go to tools, options, and say under the mesh panel that we would like to display surface faces. And right now you can see what kind of mesh we have created. Of course, it's not all. We are not satisfied with this mesh. I said we are not going to cover advanced ways of controlling the mesh resolution in the first tutorial, but we would like to refine it somehow. So we are going to change the general settings, and you've got something which is element size factor. If you decrease this value to a lower one, you can once again choose 1D and 2D, and you see that your mesh has been refined. Let's decrease this element size factor even further, and let's generate the mesh once again, 1D, 2D. So as you can see, this element size factor is the way how you can specify globally and automatically the element sizes. So you can control your mesh resolution globally, automatically, by simply manipulating this element size factor. The other way that you can do when even creating the geometry. I haven't mentioned it during creation of points, but if you go to geometry, if you move back to geometry, elementary entities at point, you will see that we have been talking about x coordinate, y and z coordinates, but additionally there is one more parameter, prescribed mesh element size at point, and once creating the geometry, you can tell to the mesh generator that you want to have a specific size of your elements at this point that you are creating. So if you specify, let's say 1/10, this would tell the mesh generator that at this particular point the size of the linear size, the length of the edge of the element should be 1/10 of your, I don't know, meter, millimeter, or whatever unit you work with. But basically, once you have, and then this element size factor is just a scaling factor which tells the mesh generator how much bigger or how smaller this your elements should be with respect with what you have defined earlier. So element size factor is not a way to specify your element size in a direct way. It is rather just a scaling factor with respect to the size, to the element sizes that you have defined somewhere earlier. All right, the final step in the first lesson is to save your mesh. So we would go to File, Save As. You don't need to go to File, Save Mesh. You can go to File, Save As. I will select it. Let's say guess from extension, and I'm giving the name first mesh, and Gmsh will guess from extension, so I need to specify the extension, which is .msh for mesh, and I hit save. I accept all the default settings. Okay. And the thing which might be pretty stupid, but I would open the mesh. I would open the mesh, and I can see the whole mesh file, which is holding, which includes these names of the boundary conditions. It also specifies the IDs of the physical groups of my boundary conditions, and then specification of all nodes, elements, and so on. Well, most often you don't need to go to the MSH file and to read it, but that's possible for people who want to manipulate or use it in their own solver. Thank you for the first tutorial, and please feel invited to the next one, where we are going to teach you how to handle 3D geometries and how to generate three-dimensional meshes, and how to influence mesh resolution in a bit more detailed way. Goodbye.